Hi, welcome. So today we're going to be having a go at Dear ImGui, Dear ImGui, or Immediate Mode GUI. And yeah, this is in C++. And yeah, I like to usually just use plain C, but today we're going to have a go at this library because it's a very, very cool library. Um, Dear ImGui. Now, if you just have a look down on this repo, we've got these couple of little cool widgets. And there's a lot of UI components that you can create very cool GUIs with. So if you just keep scrolling down, there's some very cool examples here of some pretty complicated sort of game engine sort of UIs that people have created. So yeah, so the goal of today is we're going to try and set up these couple of examples here and have them running. Now, like I said, I like to do stuff in C because yeah, I just find it a little bit simpler and it's a pretty cool language. So what we're going to try and do is compile this as C++, but then we're going to write all our stuff in C. So even though this is in C++, there is another project here called CMI that gives us bindings for C. So it's like a little wrapper that we can use to call all these functions from C. And yeah, I mean, feel free, you could still follow along with this and just use the C++ version, but I'm going to use the C ImGui version. And what we're going to actually use as our backend renderer is Sokol. So I've done another stream on setting up Sokol. So yeah, if you want to know a bit more information about that, but we will be setting up the basics of Sokol. So yeah, let's get into it. So Sokol, I sort of like to just follow this style where we've just got these simple STB style libraries where we could just include the libraries and just make our life easier than trying to have all these complicated build systems. Um, and we're going to try CMake today because we have used make, just plain make files in the past, but given this is going to be a little bit more complicated, CMake's pretty much become the industry standard, especially for C++, and I think this is going to make our build a little bit simpler. So we're going to use CMake. All right, so you can see here on Sokol, so we've got this, yeah, the core libraries. So we're going to use this one, Sokol GFX. We'll use the Sokol app, and I think that's probably all we'll use there. And then also these utility libraries, we've got the Sokol ImGui. Yep, this one. So we're going to use this one. Yeah, so let's get into it. So first up, all right, so yeah, I've got a blank directory here. Let's zoom in a little bit. There's nothing in this directory, so we'll just go straight into it and let's just start coding. So first thing, I'm going to make a makefile just because even though I'm going to use CMake, I'm actually going to also use a makefile. So we'll add a makefile, we'll add a source.main, and we'll add a CMake lists.txt file. So this is our CMake file here. So maybe let's just start off a real simple C file, standard.io.h. Okay, so we'll just start off with a real simple hello world, print hello world to the output, and we are done. So let's go to CMake. Right, so CMake, to be honest, don't know a lot about CMake. I'm still just learning it, so just bear with me while we sort of, yeah, let's try and create the minimum CMake file that we can create. So CMake always requires you to specify a version. It's sort of like the minimum version. I'm just going to say 3.15. I don't really know what version I should be using here, but this is the version that I was using and it seemed to be fine. So you do have to have CMake installed. So if you type CMake version, uh, yeah, I'm on version 4. So this is pre-installed, but yeah, whatever platform you're on, you can install CMake. So we're going to create a project here, and our project's going to be called Sokol ImGui. Does that sound? Maybe we'll call it ImGui demo. That sounds a bit more fun. And we're going to write in C, and we're also going to do C++. Um, so I'm just going to leave it at C for now, and we'll add the C++ in later as we need it. And we're going to include some directories. Include this current directory. And I think that's pretty much it. And then we can actually just add an executable. And our executable was just going to be called ImGui demo. And we're going to use a file from the source main.c. And that's probably enough, I think, to get started. We actually probably don't even need this line here, to be honest. So let's comment that out for now and see if we can compile it with the absolute minimum. So with CMake, basically you create a build folder. Okay. You then change into that build folder, and you write CMake back on the previous directory where the CMake list file is, and we get an error. Okay, unknown command CMake minimum requirement. Yeah, I've definitely spelled that wrong, haven't I? Required. There we go. Even my syntax highlighter picked that up. Okay, that seemed to work. So what that actually does, it creates all these files here, and it actually created a make file. So by default, especially on this Mac, it's generating a make file as a build system. So CMake actually just generates a make file or a makes build file to build your program. So all CMake's actually done here is generated this make file, which we could have typed that out, and we have in the past, but I mean, not one as complicated as this, but we could certainly write our own make file. But there's all this big long make file that's just now automatically generated. Actually, doesn't actually look too bad, the simple version, to be honest. But so yeah, from there we can just like hit make and make. And now we've got this ImGui executable. ImGui demo. And hello world. Okay, cool. So yeah, let's what we're going to do now, I usually create this depth folder where I put all my dependencies. So in here, I've actually got, we actually want to use sort of import all these files. So what I'd usually do is come in here and find the files that I want. So I want this Sokol app and Sokol GFX one as a dependency. So, but what I've actually done before, I've actually pre-created some of these as like a make script. So what I'm going to do is just grab them all in my make script. So what I'm actually doing here, so this is probably a little bit confusing, but we've got a build folder. This is my actual building my program. And I'm actually going to use make files here just as like a utility script runner. It's just going to run a heap of commands for me. So I've just copied this from a previous repo because I've done this before. So I've just got a make task here to do update Sokol. And what it's going to do is go and fetch that file from GitHub. So you can see here, this is the repo, but basically this is a raw file, and to find that URL, you just come into Sokol repo, and so for example app, you click on this app here, and then GitHub gives you this raw version, and you can click on that, and that will take you to this URL, and that's the raw URL that you can just download directly. So I'm just using wget. You can use curl, doesn't really matter, just something to download the file, and it's going to put it into this depths folder. So we're going to get the Sokol app. I don't want audio. Glues. So this is the graphics library. The glue basically connects sort of the app and um, the graphics together. I don't need time. We might just keep the logger. And yeah, this is the other one that we were sort of looking at before, the utility one for in Sokol ImGui. So that's going to be our Sokol ImGui bindings. So if we're going back to Sokol, you can see here that there is a utility folder, And in here, there's like, yeah, different, um, you can sort of bind Sokol to different libraries, but we're using this Sokol ImGui one. Okay, so yeah, all right, so now, yeah, I can just run this make task now, and we should just end up with, so I'm in build folder, so I've just got to go back to make and make update. Um, no rule. Why have I got no rule? Did I not save that? Oh, I mustn't have saved my make file. Okay, so now we've got that all downloaded, and you can see here we've got all these files directly in our repo already. Okay, cool. And the other ones that I want to actually get, I just want to show you is the, what I explained before was a CMI GUI. So we've got this one here, CMI GUI. So this is the C bindings to ImGui. And in here, there's a master branch, but there's also this docking branch. So in this docking branch, it's ImGui's got this like nice docking feature where you can like dock windows and stuff, and it's actually really cool. So I'm going to use that version. It's the same as on the ImGui. There's a branch. I don't know why it hasn't gone into the master branch yet, but there's this docking branch. So we're going to use that one, that version of it. And in here, so when I go to that branch, the docking branch, what I really need here is these like CMI GUI files here, the C++ ones, the header files, and a couple of these C++ files. And then in here, there's actually a link to the, it's a submodule of Git that there's a link to the ImGui. But if you actually look at this, this is like on a particular commit hash. So this is the commit hash that these C bindings work for. So we've got to make sure that we use this commit hash here. So when we're going to download ImGui, you'd have to make sure that you go and find, basically in ImGui, we're going to just basically download all these files here. And you just click into each one of these and hit the raw, and you can see that that's on that exact commit hash, not off the sort of the master branch. So yeah, what I've done, so to save a bit of time, I've actually sort of pre-done all that because yeah, there's a bit of sort of time in trying to get all those URLs correct. And I mean, you can just download them once and be done with it, and just put them in your repo. But I like to just sort of script it up, make it a script that I can just like reproduce, and then if I want to do an update, I can just run that script again and sort of update the sort of dependencies, I guess. But I'm in control of when that update happens, so I can just sort of update at any point. So you can see here, I've got update CMI GUI. So this will download all those CMI GUI files. So we've got a config file, C++, and a header file. And you can see here the branch. So the main thing, see these ones are on the master branch, whereas this one's on the docking branch over here. And then the ImGui is actually on this commit hash. So that will give me all the files that I need. And if I run this one, this should also run this one. So if I run update CMI GUI, update CMI GUI, and maybe I didn't save that, I don't know. No such file or directory. That is a little bit strange. Let's click that link to see where it takes us. Oh, let's just run it manually. Oh, okay, yeah. So what it's actually complaining about, my bad, is that I'm trying to save it to the steps folder, but actually in a folder CMI GUI, ImGui. So I'm sort of trying to keep the same folder structure as what they had in Git. And yeah, you've actually got to make those folders yourself. I could put that as part of this script, but I'm just going to manually make those folders. So I only ever want to do it once. Okay, so now I've got that folder structure. Let's just run this again and hopefully we get, yeah, some better results. Here we go. So it's now downloading all those files for it. Okay, and here we go. So you can see here we've got all the files we need. I think this is all we need. And you can, I mean, just to make this simpler, if you want to do an update in the future, you can just write update deps, dependencies, I call it deps. And you could just sort of look up Sokol and update ImGui. All right, and yeah, so let's yeah, so we've got this CMI GUI here, and we've got this sort of like our C++ files, our um, header files. So this is the set. These are like the bindings. So you can, if you actually look at this file, you can see it's like a heaps of struct definitions, sort of all the C definitions. I think these are all auto-generated from the original, and you can see here, yeah, these are like these are the actual bindings. So you can see it sort of like creates a C wrapper around every function. So this one here is show about window, and it's just got this IG prefix, ImGui prefix, IG, and that actually underlying that calls the C++ version of that. So basically just converts C to C++. But I mean, if you're just doing this in straight C++, you would just use the ImGui library. Um, so yeah, and the good thing about this, the Sokol ImGui library, if you read this header file, this is basically the bindings between Sokol and ImGui. It says that you can use either. So here, the implementation can be compiled as either C++ or C. So when it's compiled as C, it uses Sokol imgui.h will directly call into the imgui API. So it'll essentially directly call this imgui header file. But if you're using the C version, it'll call this C imgui. So very nice library. The Sokol Lime GUI is very flexible and very nice. So yeah, let's get into it. So Sokol, yeah. So the first thing we just need to do is basically let's create a window and see if we can get this app working. So we actually, when you create a Sokol, you don't use the main function. You actually use the Sokol app main function. So we create a description and it's called Sokol main. Um, and instead of taking a void, it should just take arguments and argc and argv, which is sort of the standard. So yeah, that's what we need to do. So before we actually do that, we actually need to import these files into our build system. So we should be able to say sokol app.h. Oh, right. Yeah. So we get some errors here. So what we actually need to do here is we need to include this into our build system. So we go back to our CMake. You can see here this include directories. I'll include the current directory. I don't know if you need to do that or not, but we actually want to include the dependencies directory, right? So what that is like, because that's where all our files are stored. So we just want to include deps, and we actually want to include imgui. So that'll sort of include all this as well. All right. Oh, and so uh, yeah, so normally what we've got to do is define Sokol implementation somewhere. So what I'm going to do, I'm actually going to do that here. So I'm going to create a deps.c file and I'm going to include all the Sokol files here. So yeah, as you can see here, we need to define this Sokol implementation. So I'll define that here. And then from there, I can just include all my Sokol files. Sokol app, Sokol GFX, the Sokol glue file, and we'll include the log file. H. Okay, so even though that's complaining, I think we can now add that to here. And we should be able to now build that. So we go back to our build and we just run make. and we get an error, which is probably expected, I guess. So we actually need to return this app description. Okay, and yeah, let's just include a blank one for now. I mean, that might work, sort of. Okay, that's cool. That's starting to work. So yeah, what do we need to do here? We really probably just need to get this here to be compiling. So if you see my other video on Sokol, we basically need to add sort of a heap of like frameworks and different compile flags to actually get Sokol to compile. And I went into a lot of detail in the other video, but you can see here we sort of need to define these headers depending on which backend you're using, whether you're using GL Core, Metal, DirectX, or you're using like Web GPU. So there's sort of different options that you need to sort of specify. And when you're compiling on like Mac, which I'm compiling Mac, you need to sort of include these backends such as Foundation, Cocoa, and Quartz. So once again, I'm just going to steal a little bit of code. I don't like to do this too much, but it's just going to save us a little bit of time. And I will include a link to this in the notes, but we'll commit this to Git. So this is some code that yeah, I've sort of developed. And basically here, it's just sort of determining the platform. So if we're on Apple, which we are, and like if we were just doing this for just the platform you're on, you don't necessarily have to do this cross-platform thing, but we're trying to make this a cross-platform app. And one of the benefits of using CMake is that we can, it makes running cross-platform a bit easier. So we can say if we're on Apple, we're going to set this backend flag, and we're going to set a define variable. So we're going to define Sokol metal, which is kind of, if you look in the app description up here, it's sort of doing the same thing. So you can actually use this define in the code like this. So you can say define and then the define variable, or you can actually just pass it as a flag to the compiler, which is in our case is what we're going to do. So we're actually going to pass that dash D is the define, and then the define variable name. So you can always pass a define into the compiler through a dash D. And then we're going to set some platform libraries. So as said, we need to include Cocoa, Quartz, Metal, and Metal Kit. And the other thing, because we're on Mac, everything's basically written in Objective-C. And as you can see here, we're getting all these errors basically because these are objective. Some of these are objectives. Whenever you say NS, which is next step, which is the operating system, the original Unix operating system that Mac OS was written on. This is basically Objective-C code. So we're getting these Objective-C errors because we're not compiling with Objective-C. So we basically just say we want to compile with Objective-C. And yeah, if you're on Windows, these are sort of the Windows flags. I just got this off somewhere else. I think I got it out of a make file and converted it to a CMake file. So and same with Linux. This is just using the OpenGL core and just passing OpenGL library, mass library, pthread, and DL library. So I haven't tested this on Mac or Windows. So yeah, let me know if that works if you're on those platforms. So yeah, we've added them, and then we basically just need to sort of tell we need to sort of add those definitions. So there's an add definition, and we've got this backend variable here. So we basically just whatever our backend variable is, which we're setting there, we just need to set that as a definition. And what else do we have to do? And then we just, yeah, we need to target these. We sort of need to link to these libraries. So our app name is, our executable name is ImGui demo. and we now want to link to this these. See, we've basically just created a variable here. So we've created two variables. Um, is the backend variable, which we add as our definitions, and we add a platform libs. So we're just going to target these link libraries um, down here. So like if I was just on Mac, I could just sort of come in and just like, if I only wanted to compile this for Mac, um, oops, I could just come in here and sort of grab that string and just add that in there, hard code that in there like that. But then that's obviously not very sort of cross-platform friendly. So instead we sort of create these variables and then set the variable at the end. So yeah, let's set this variable called platform libs. Um, I think that's about it. So let's just so basically yeah. So I mean we've just got it. It's a relative straightforward CMake file. Set the minimum version, create a project, include some directories, and set some custom um, variables depending on the platform, and then we add the definitions. That doesn't look right, does it? Because I'm getting a yeah, I think this is definitions with an S. That looks better. Different color. So add the definitions that we specified here, and then we set the platform libs to link to those libraries, and we're creating this executable from these two files. So I only want to create it from these C files. So let's just run it and see what happens. Okay. So that cannot link libraries. So maybe I've using my most of my issues are always spelling issues. That looks pretty good. Target link libraries. Yeah, I don't know. That seems pretty good. Um, yeah, I don't know. I mean, I can. So the good thing about CMake is that you end up sort of putting all your build artifacts in this build folder, and it doesn't have to be build folder. You can really put them anywhere, but I can just like remove this build folder, and I can just sort of recreate it. I don't know if this is going to actually fix my problem, but um, let's just see. Yeah, I think there's a CMake regenerate. You can regenerate that rather than actually doing what I just did, but I forget the exact command. Um, not built for this project, yeah. All right, I'm going to have a short break and I'll keep debugging this and see if I can figure out what I've done wrong. So, all right, we'll catch you shortly. Okay, I've figured out what it was. So it's just that I've got this comma here. So I'm used to sort of programming languages that have commas between arguments, but yeah, in CMake it's just spaces. So it's a sort of funny language, CMake, but it is what it is. And like yeah, like I said, I'm just sort of learning it. So anyway, I think this is. I'm hoping that will work. Okay, so that's now worked, and we can now run make on this, and hopefully we get yeah we got an executable. Okay, cool. So I don't know if this will run, but let's just see what happens. Okay, it actually ran. And we've got a window. So yeah, there you go. So we've set up Sokol very quickly using CMake, and we've got some yeah CMI GUIs ready to go. So all right, I'll see you in the next video. All right, so we're back. In the last video, we just had we set up Sokol, and we've set up a very, very, very basic Sokol app, and yeah, got it up and running. So the next step is we've actually got a few errors here. So we're just going to try to fix these errors. Even though, yeah, it's actually running. So if I hit make, it builds it, and I've got an executable that I can run. And we get a nice little window. But my ID using NeoVim is actually giving me a few errors. So it's just not quite communicating properly. So one of the ways to fix this is that there is a little thing, and I had to once again Google this, that I can actually put in my CMake file. And let's just put that, say, here. So we can set a variable, and the variable is called CMake export compile commands. And I don't know if this is only a Clang thing, so I'm using Clang as my compiler. Just like Clang is the actual compiler that it's using. So I don't know if this will work on other platforms or if you're using a different compiler, but this is works for anyone that's using Clang. Potentially used on other platforms as well, but I'm not going to say for sure. So yeah, we export those compiler commands. Now, when we, yeah, that should generate, yeah, it does. So it generates these compiler commands here. So it generates this compiler commands file, right? And so in here, it's basically the build instructions, right, that we use to build the program. So you can see here, even though it says CC is an alias for Clang on this Mac, I think. I think. Can I go CC version? There we go. Yeah, so it's Clang. So yeah, so I'm running this, and these are the, as I was talking about in the previous video, we define the so-called metal variable, and we've got some includes. These are the include directories. So these are the actual commands that are getting ran, and this is our input file, and this is the output file. So our IDE, can't remember exactly. I set up an LSP for Clang so it can actually read this file. So I could go into NeoVim tutorial another day, but basically I've got it set up so Clang is an LSP so it can read this file. So if now that I've got that file, I still don't think this will work. Let me just quit NeoVim and restart. Oh no, that did work. Okay, cool. There you go. Yep, so that's working. So I can now hover over these like this struct and hit GD, go to definition, and actually go straight into there and view the source. So it's very, very, very nice. Yeah. Okay, cool. So next thing is what we're going to try and do is I'm just going to make it a little bit easier for myself. I kind of really like Make. I like Make files. And even though we're using CMake as our build system, just because we want to sort of provide a bit more of a cross-platform experience, Make is not always available on every platform. I mean, you can definitely get it on every platform, but CMake, if you're on Windows, it's probably a little bit more accessible. So, but I still like using Make as my sort of like utility script runner. So what we're actually planning on doing here, and it's a bit of a funny system, it's a little bit unconventional, so I'm not suggesting people do all this, but this is just how I like to work. So CMake, if you want to compile the goal of this program would be that you compile this program on any platform. So you can just go to any platform and compile it, and the only tool you need is a C compiler and CMake. But if you want to sort of do additional work, not just compile the repo, but maybe like actually work on the repo, run it, test it, update the dependencies, you would sort of the system you'd want would be this make file. So yeah, so it's a bit strange. So what I'm actually going to do is use make to run CMake, and then CMake. So this make file in the root directory will run CMake, and then CMake will run this make file that it generates. So yeah, it seems a little bit backwards, but it works for me. So yeah, I'm just going to do it this way. So what we want to do is I'm going to just create a little target here called CMake build. And what it's going to do, actually, yeah, let's actually create a build target. So in our build target, what we actually want to do is make a directory called build. So sorry, this is a target. We're going to make this build directory. So to make this build directory, um, yeah, we're gonna make the directory build, and then we're gonna CMake it and build it. Um, so how does this work? So let's sort of do this step manually, and then we'll make the makefile for it. So I'm just going to remove the build directory for a start. So the first step is to make the build directory. So in the previous video, I was cding into the build directory and calling back, but what you can actually do instead is you can run CMake and say -b and specify the build directory. But you have to make it first. So we CMake it and we say the build directory is build. Okay, and then that has now put all the files into the build directory. So you can see there, but we want to stay in the root directory. So then from there, we can actually now say CMake and we can say -build. And so we actually want to build the contents in the build directory. So this is basically running the makefile in the build directory. So the build directory is build. So there's a lot of building going on in this, but that's what you get with CMake. And there we go. And we built it. And then from there, from the build directory, we can run our executable. And you can see there we go, and it's running. Um, can you actually see that window? Oh, you can. Okay, cool. I don't know if that window was popping up in my OBS. All right, so yeah, so we're just basically I just want to put all those steps into a makefile just because yeah, CMake it is sort of like a lot of steps and you sort of forget what they are. Well, I do. So we've got a build step and we're going to have a CMake build, which will be the second step. So we want to do the build first, so that sort of creates the build folder, and then from there we're going to run CMake. Sorry, we're going to make CMake, and we're going to pass that build and build. So, and then I'm just going to put a little thing up here, all. So all, it's just a bit of convention in make. It's sort of like the first task. So if you just run make without passing a target, it'll just run this one. So a default target I want to be the CMake build. So now if I just run, let's actually remove that directory one more time. Okay, so the directory's gone. We hit make, and yeah, there we go, that worked. So it created the directory, ran CMake build, and then ran, yeah, so I actually hid that command. So this @ symbol doesn't show you the command that it runs because I just want to hide that. So then when I run make again, it just runs it. Yeah, and then the other one I want to do is run. I like to, so before we run it, we're going to make sure that it's built using CMake, and I don't want to show the command of run, but we're going to, from the build directory, we'll run this ImGui demo. I think it was what it was called. So now I can say make run, and we've got our program. Okay, cool. So that's just a little crazy backwards sort of way of calling CMake, calling make. But yeah, I mean with CMake you don't have to use make. You could use Ninja. There's a Ninja build system, so I think you can pass like a -ninja flag, and then that will build using Ninja. So and there's other build systems that you can use as well. So um, yeah. Anyway, that's just a little trick that I'm doing. So you'll see when I make run, you know what I'm doing. Okay. I will see you in the next video. All right, so we're back. We're going to now set up some ImGui. We're just going to have a bit more go at setting up a bit more Sokol. So we've sort of got this main running here. We can run make run, and we've got a window, and all is looking good. But what we want to do, when we return this app description, we can kind of define a few things about the app. Um, and one of the main things we really want to define is probably like the width and the height of the window and these sort of functions here. Okay, so let's just go back into our app, and these are the functions we want to define. So, oops. So we have a .init function. So the init, this is actually a init callback function. I'm just going to call it init. We have a frame callback. I'm going to call this one frame. So creative. We'll have a cleanup callback. Call this cleanup, and we'll have an event callback. We'll call event. Okay, and while we're going, we probably could set the width, and let's set it at 800, and let's set the height at 600 pixels. Oh, and we can set a window title too, so let's do that. Window title, and we can just set that to whatever we want, but let's call it ImGui. ImGui demo with Sokol. Maybe like that. Okay, so these functions are undefined, right? So when we let's just create them. So this one's a init's a void function with no arguments. We want a frame function is also the same. We have a cleanup function, oops, which is also void. So returns void, returns nothing, takes no parameters. So we'll have cleanup. And we'll also have an event function. All right, and event. So the event actually takes an event object, event struct, as its parameters. So that's our event function. So you can just run it. Yep, that's looking good. Okay, now one thing, I'm just going to pinch one more snippet of code. I had a whole video on doing this bit last time in the Sokol video. So in the event function, basically what I want to do is say if the key is down, so we can actually get this event object here, and it's got lots of different event information, such as the type and some mouse events, lots of different sort of, depending on the event. So we actually say check the type, and if the type is a key down, so there's, once again, there's lots of different type of events that you can get. So we're looking for a key down event, and then if that's true and the key code is the escape code, right? So we're basically hit the escape key is what that means. We want to just quit the app. And you wouldn't normally release an app like this, but I just find it very handy in while I'm developing that I can just go make run and hit escape, and I'm sort of exit it just to really quickly iterate. Okay, so yeah, just put that in there. Yeah, we don't need this anymore, so let's clean this up. We don't really need the hello world anymore. Oh, and yeah, you can see now our window's different size, and it's got a nice little title, so that looks like that's all working good. Right, now let's try and compile some ImGui. So yeah, first step is sort of look at this Sokol ImGui, and in here we need to define that. We've already done that. Or Sokol ImGui Yeah, actually, we do need to define this again. So what I'm going to do, because this is going to be in C++, and I'm trying to compile this as C, I'm actually going to create a C++ file. So we're going to add another dependency file, right? And I'm going to include this Sokol file. And yes, what it's telling me is that I need to include this definition. So this is out of these definitions. This one's basically like the general one. You just include this one, and that sort of says implementation for all of them, or you'd have the implementation for the specific Sokol. That's sort of a pattern that you'll see across all the Sokol apps. You see here's like Sokol, just general Sokol implementation, or Sokol for that specific app. So in this case, because we're only doing in this depth file, we've got the implementation for all these, the sort of the base Sokol ones. And then this one, we're doing the definition for ImGui. Okay, so it's now telling me I need to include the so-called GFX. And also app. Okay, so let's include that. Okay, so that's sort of working. Now it's saying include the CMI GUI header. Okay, so we can do that. So in here, we'll call the let's put the ImGui header. Potentially what we need to do here is actually add this to our build system. Let's just make this and see what happens. Ah, yeah, so we haven't included into our CMake. So what we're going to do here is include our deps.c++. Okay, and we probably just want to say here that we're actually not just doing C, we're actually going to do C++ as well. So C++ is CXX, which seems a little bit strange, but that's what it is. Okay, sort of worked. Yeah, so it's still trying to const expression. That's a C++ thing. So it's basically trying to include this as yeah. So we actually need to include all those. We sort of need to compile all the C files basically. So in these C files that we're creating here are really just to like include these single file headers as implementations, right? So you can see here app. So there's always the sort of the header part of the file, and then eventually you get into the implementation, um, which is sort of here, right? And so this is really like this input from this bit onwards would be equivalent to having a so-called app.c file. So this is like the C file. And so basically by defining this, you sort of get that C file essentially becomes a C file. And we could just include that directly in our main and define it in the main function, but I just like to create this depth folder so I don't have to keep recompiling all the time. So this is kind of like our C file for all these embedded in one. And so we're compiling that, and we're doing the depth one for this Sokol ImGui. But in here, we've got all these other C files or C++ files, right? So we don't need to compile the header files because they just get included, but we need to compile all the C and C++ files. So you can see here we've got all these C++ files. So we need to actually include them into our build. So we're going to do that in our CMake. And yeah, I've actually done this before as well. So I'm just going to kind of steal this little bit of code that I've had over here. And you can see here, so this is literally just all those files. So I just had to go through here, and to save a bit of time, I've pre-done this, but we just have to go through and include all these C++ files, right, into our build. So now you can see everything we're compiling is always a C or a C++ file. And because we're using both C and C++, I think the way CMake works, could be wrong, but I think this is just basically picking up the extension and compiling. If it's CPP, it's using the C++ compiler, otherwise it's using the C compiler. So let's just see what happens there. Okay, so we go. No, I don't know if that made it worse, to be honest. Yeah, so maybe the other thing I did find that I did, I don't know if this will help, but let's try it anyway. So we actually just set the C standard that we're using because potentially that constant expression thing is a relatively new thing to C++. I'm definitely not a C++ expert, so I don't really know. I think it might be relatively new. I don't think it's in the old C++, and yeah, I'm not actually sure, but we're just going to set the C standards, C standard 11. So we're going to use C standard 11, and we're actually going to set the C++ standard to C20, C++ 20, and this might help. So basically telling the compiler what version of C++ we're using. And from memory, I think I got those versions from here somewhere, but I'm got to admit, I can't remember where I got them from. Okay, I think that did something, to be honest. Yeah, I think that was progress. Yeah, it's definitely progress. Um, yeah, I'm not sure what I'm actually missing there. Okay, well that error's actually gone away now. Hmm. All right, well I'm gonna have another little small break, and we'll see if we can debug this, and I'll yeah, come back to you with what I found out. Okay, I think I've found the issue, and after a long bit of searching, is yeah, this is why you don't copy and paste stuff, because it has bit me. So I'm getting these errors, and I wasn't really sure why. And the reason is, I think we're about to test it. Is that in the starting video, we ran these little scripts here to get these from GitHub. Now, because I copied this from a previous time that I've done this CMI GUI is actually just locked on this this tag or this this branch. So this Docker inter. And at the time, that branch was connected to this git hash in the actual ImGui library. So if I show you in GitHub, you'll know what I'm talking about. So in this, where was it? Here, CMI GUI. So I'm on this Docker int branch, and then this is using this Git submodules. At the time, I'd copied the Git hash, and it turns out well, that was the right Git hash at the time, but since then they've updated this Git hash to the submodule. So they've updated the submodule with the branch, and now this is the new Git hash. So there's been some sort of breaking changes, I guess, that are incompatible. So you sort of, if you're using the C bindings, which I'm using, you really need to make sure that whatever version you're using here, and what we could have done is actually lock the hash of this CMI GUI to make sure it's sort of stable. But I was just actually using the branch name on this one and then the hash name on this one. So we've sort of gotten caught out. So basically I just need to update this hash here like this, I believe. Yeah, so what I need to do is search for all of them and paste that. Paste that hash that I got here into my script. Okay, I think that's, oh, yeah, sorry, you probably can't quite see that. It might be cut off the screen a little bit. Um, I'll try and move it across here. Basically, this hash in this file here is wrong. So yeah. Anyway, and this is why we do this is why we've got this update command. I can now just update ImGui. And yeah, so hopefully this update, if we actually just look at the diff, we actually don't have this as a Git repo. Oh yeah, anyway, it doesn't matter. We didn't check it in, so we can't really see the diff. Anyway, so yeah, that's from what I've figured out before. There was definitely some diffs, so there's some issues. So let's just make this now and see what happens. It already looks better, and it looks way better. Okay, cool. So we're now running. Make run, and we've still got a window. Okay, so now we've compiled. So we've successfully compiled ImGui and linked to it. And now we're just, the next step will be to sort of include that into our Sokol program. So I'll see you on the next one. All right, so now we're going to try and install, use this ImGui into our app. So we're building it. We've built it with ImGui. We're linking to it. Now we just need to actually start using it. So first step is really just to start including it. So let's just include imgui.h. Now, as I was explaining before, you can see here that these, let's actually just make a clean build. And let's go make. Oh, I think that's just because I included this here. Let me just do this again. Yeah, so you can see here, so these CMake is actually smart enough to detect that this is a C file, so it uses the C compiler. And this one also, the deps.c is using C compiler, but these other CPP files, C++ files, are using the CXX compiler, which is C++. All right, so let's include the CMI GUI, and we also need to include the Sokol library to sort of do the setup. So this is the Sokol sort of bindings to CMI GUI, and yeah, that looks okay. Now, just from experience from doing this before, there is this there's sort of this header definition. Where is it? This one. So in here, they define this sort of CMI GUI define enums and structs. So that's sort of because we're using the C version, it sort of defines all these structs down here, these C structs. So I guess if you're doing C++, you obviously don't need to do that, but for whatever reason, we need to actually also define this variable here. So we define that. Okay, and it also says we need when we include this Sokol ImGui, we just need to include Sokol gfx.head.h. Okay, so let's just try and build that. That looks good. All right, now, yeah, let's try and like sort of initialize it, I guess. So we actually didn't actually set up anything in our init function, which is surprising. I actually thought that you actually needed to. Well, I guess we're actually not doing any graphics. So normally you'd set up once we set up our graphics library, but all we've done is really just set up the app, and you can see when we go make run, we get our window. So all we're doing at the moment, we've got a window, but we actually need like a graphics context first. So in the GFX library, there is this function, this setup function. Yeah, so-called setup. So we just sort of need to set up this function. So what we just need to do there is just call this function, this setup function, and we need to pass it a description. Okay, and it's a pointer to description, so we can just use I think they're called struct literals, but correct me if I'm wrong. And yeah, we need to put that in brackets. Yeah, and here we put the environment, and this is where we can use our glue file, which we haven't even included. Okay, I might have spelled that wrong. There we go. Yeah. So that just basically sort of it sort of sets up the app, sort of grabs configuration from the app and sets it up into the so-called GFX setup. I don't actually know what it does, but it seems to work. And yeah, we don't really need to do this, but there is this logger. We can set this log function. And once again, we haven't included the logger. Okay, and that looks pretty good. Okay. All right. Now, yeah, so next step is if we sort of look through this, the Sokol ImGui library, we've sort of got set up all these build steps as we've been going. There's a few options there. You can actually define that prefix. I think we talked about that before, the IG prefix, but yeah, the default is IG, so we'll just stick with that. But yeah, how to initialize. So this is how to initialize the app here. So we just need this S Sokol ImGui setup function. So we just need to call that to initialize it. So we go back into our main and let's just paste that one in here. And we can just sort of inline this again as well. I've got these inline hints going on and I must admit they're a little bit annoying. I think I need to turn them off. Um, so I don't know what this takes. Let's just make this 0 for a start. Okay, there's a few different options here. But yeah, hopefully we actually don't need to worry about that. We can just use the defaults. So yeah, let's just set that to 0. And yeah, and there's actually a cleanup function. So we probably should just put our cleanup function here as well. So we're sort of doing the reverse now. So we sort of set up the so-called graphics and then we set up ImGui. And now we'll just sort of do it in reverse order. So we'll do the ImGui shutdown. And yeah, that's definitely a function. And we'll do the so-called graphics shutdown. Okay, and yeah, that's it. Let's just run that. Okay, that builds. Um, yeah, oh, yeah, so now in our frame. Okay, that's right. So in our frame, there is in here, back as we were sort of following this, where were we? Sorry, I'm all over the place a bit here. So we're following this along. We ran our setup function, which is good. Heaps of different options there we can read. Yeah. Now at the start of a frame, we need to call this. Okay. So every frame we need to call this sort of this function. So here's our frame function here. Put that here. Just a bit of indenting. And yeah, like we just need to set these variables. So like here, the width, so we can actually get this from our app, our Sokol app. The height we can also get from our Sokol app. Delta time, we can actually also get that from our app, which is the frame duration. And yeah, there's one more we can also get, which is Sokol app DPI scale. So we basically get all these same things just from the app. So I don't know if it actually, oh yeah, I knew I got that from somewhere. So in this example here, it sort of explains here exactly what we need to do. And then, so yeah, we've just basically done this bit. And then now we need to just render it. I think there's another step. I'll just have another look. So we just render the frame. Um, Semicolon. We potentially need to set up a render pass with the so-called graphics, but I'm just going to run this and see if it works. It sort of works. Um, well, given that that worked, I thought I had to do a render pass, but maybe I don't. So maybe we just, yeah, it probably won't work, but let's just try it anyway. So let's draw something. Let's just create another little function here. Let's call GUI draw. I mean, we can just put it here, but I'm just going to put this in another function here. GUI draw. Make, yep. Okay. So I think the first thing we need to do is just create a window. Let's actually go back to our original plan and see if we can kind of maybe just draw this bit of text. I have no idea if it's going to work. Let's try it. Now, as I said at the start, this is in C++. So we're going to try and convert it to C. I mean, we could just compile this in C++, but I think it's more fun. So basically everything, this in C++, you have this namespace. C doesn't have namespaces, but like all that really means is you just don't need to put the two double dots, right? And then you've got a namespace. So, I mean, obviously you can do more with namespaces, but in this version, we're just using IG as our namespace, and then we can just call this function exactly the same. Hello. Well, yeah, instead of actually typing that out, I'm just going to actually put like that and replace this bit with IG. Yeah, and all that actually, that works. So let's just run that, see what happens. Oh yeah, so it did fail. Okay, kind of what I was kind of expecting actually. So it says you must call a render pass. Okay, so that's actually coming from Sokol. So I kind of expected that, so that's kind of good. So yeah, we actually need to set up a render pass. So I have done this in another video, the Sokol video. So yeah, what we actually done, we actually sort of need to, let's have a look. Yeah, we might actually set a background color first, I think. So let's have a go at that. So usually in these ones, we usually create a bit of a like a state variable um, as like a struct. So it's like the application state, and then we sort of create a like global application state, and we just sort of initialize it to 0. Um, don't know what's wrong there. That looks kind of good to me, but it's just a warning. Um, Actually, sorry, I'm just looking how I done it another time. I think, yeah, that's probably just simpler. We'll just do a static and we'll sort of not even name it. Yeah, it's still the same warning, but it's just a little bit simpler. It's basically we're defining a struct only once, so we're not going to ever create another struct. We've just got a single global state, and we're going to start putting some variables in here. So the this is sort of where we'd put our application state in a global sense. Um, and yeah, we just want this SG pass action, and it's just a pass action. That's all we really need to do. And then down here, probably in our setup, where was our setup function? Oh, yeah, our init function. Yeah, after we've kind of configured everything, we're just going to initialize this state and initialize the pass action to our sort of background color. So we want an SG pass action. And in the pass action, there's a color. So we're going to set, so you can actually see there's an array of colors, and we're going to set the very first one, first action, to a color. That should be, and we're going to, there's a load action, and the load action is clear. Right, so we basically clear the background color, and then we actually set the clear value. The clear value, and this will be just an RGB color, including an alpha. So let's just do red first. So maybe we go a fairly red color, and then we'll go blue, oh, green, sorry, red, green. Let's no green. Let's go no blue, and let's go full alpha. Yeah, that's not a semicolon, that's a comma. So we should get a red. Oh, we still got a panic. All right, not a panic, yeah, I'm just going to comment out this text thing here for now. Oh, yeah, okay. So let's just set the global variable to the color. Okay, so all we've done really is like set our state variable to this like pass action. And then now in our frame function, we're going to create a um, pass action. So we're basically going to begin a pass action. So we go SG begin pass. So this is basically beginning the render pass. And in the render pass, we're just going to have a pass action, and the pass action is going to come from the state. So now we're just getting that state variable that we set before. And there's also this swap chain, which I believe sort of swaps the buffers. So we're going to use our glue function for that. Okay, and that's looking pretty good, I think. Yep. So we're basically beginning our render pass. So we sort of call these draw functions like in this like we call these ImGui functions that sort of perform all these actions. We begin a render pass, we render the ImGui, and then once that's done, we call SG, so Sokol graphics end pass. So that will finish our render pass. And then we actually got to commit that. Okay, so hopefully, there we go. There's our nice red. That's terribly ugly, but it was just a big flash to make sure it's working. So I'm going to just change that color to something a little bit more nicer. Let's just change it to all sixes. We'll get a nice sort of grey color. Yeah, I feel like we need maybe a little bit less. Oops, that's better. Kind of back to that nice grey color we had originally. But the main thing is here we're actually starting um, a render pass, and we're doing this swap action. And yeah, we probably didn't even need to set the color, but I just like to do that. And yeah, we've got our so-called our ImGui renderer. So now that that's working, let's try our text. Let's see if this works. I have no idea if it will. Oh, there you go. So there we go. And now we've got this, yeah, we've got this bit of text that's rendering it there. It's not actually a window, so I can't actually grab it and move it, but yeah, it's actually rendering it, so that's pretty cool. So yeah, then, I mean, now we're kind of, yeah, done. So let's just try and, I might just comment this out, and let's just grab the example straight from there, from C++, and let's do a quick little bit of Vim magic where we highlight all the ImGui and replace that with IG globally, and oh, that didn't work. Ah, sorry, I buggered up my Vim macro. My Vim, not macro, substitution command. That's better. Okay. So we've got a few little issues here that we could probably try and fix. IG button takes a label and a size. So let's just pass it a ImVec, I think it was. Is that what it was? ImVec2. Um, I guess I just do it like this. What is an ImVec? Yeah, it's just two floats. So I guess this is a size. I don't know what size we want this. What have I done here? Oh, that's why this wasn't working because I had the brackets. Yeah, I think I can inline this. I think I just want to inline this. And vec2. There we go. So yeah, we're going to call a save function. There's my save function. It does nothing. I'm missing another bracket there. Okay. So let's just ignore those two for a start. Yeah, there's our button. It's about, yeah, it's a bit small, isn't it? I guess it's 10 by 10. So we probably want to go 50 by 30, 40. I don't know. Yeah, there we go. There's our save button. Cool. So we need a little buffer here to take in a string. So I guess we could probably just quickly create a static buffer. Buff. Let's just make it 512. And the size here is just 512. Yeah, you find with some of these functions using the C version that because in C++ you can have optional parameters, so you don't have to pass them all in. But in C, you sort of have to pass. They have to be fixed. They all have to be fixed. So the C++ version, like these last few options, are basically optional, whereas in the C version, you have to pass every single parameter. So you just pass a few zeros here. Maybe we need one more. There we go. And yeah, so we've got an input box there now. Let's just run that. Okay, there we go. So we've got an input box. I can't actually type. Oh, so we're not actually receiving any events. That's why we need to set up the events. So yeah, maybe we might just end that video there and then we'll come back in the next one and we'll fix up the events and do the last little bit. So all right, I'll see you in the next one. Right, here we are. So we're nearly there. We've been building our ImGui demo, and when I run it, we've got this ImGui running in the Sokol app. But you can see that when I click on these buttons, it's sort of got no interactivity, and that is because in Sokol we have this event. You can see here this is event here, this event function, and at the moment we're just listening to the escape key to quit the app just while we're developing. So this is development only. And then basically what we need to do is take these events and pass them to ImGui. But the so-called ImGui header file includes a nice little helper function here for us that we can just say ImGui handle event and pass our event object in. And that will basically pass, let's see what this actually does. Yeah, it basically converts the so-called event to potentially an ImGui event. Yeah, looks sort of how that essentially works. So yeah, run it and let's hopefully, yeah, there we go. Look at that. We can now we're getting a bit of hover. Oh, I've got a window. I can actually move that now. That's pretty cool. And we've got a tech input box and I can, yeah, I can type. I am GUI with C is fun. There we go. So look at that. We've got a bit of interactivity. So let's just see if we can get our last little widget working. So the last little one was our slider float. So let's add that. We need a variable, so let's just create another. I mean, we probably should really put these in our state if you're going to sort of store these, but I'm just going to be lazy and put them right there like that. And future arguments, same thing. There's a heap of optional parameters at the end. So let's just pass a few zeros in and see what happens. It looks pretty good. So it's just a format and a flag. So zero is usually a good default. You probably really should read the documentation to find out what it actually means, but let's just do it. There we go. And we're going to float. Can we actually drag our slider? And there we go. We actually, yeah, we're dragging our slider. So that's really cool. Let's just see if that's actually, so that should be storing that in this float variable. So every frame, maybe every frame, I don't know if this is a good idea. Let's just print it. Let's just print our float value. So it's zero, you can see it's printing zero, and as I slide it, yeah, you can see that number, that global variable changing dynamically. Oh, actually, sorry, one more thing before we finish. Let's also just print our text as well. So maybe we'll format it like this, and we'll just put our text, which was, I think, was just stored in buff. I don't know if it put as a null terminator behind it. Let's just see. 10. Oh, yeah, look at that. And we can change this. So there you go. So you've basically got this Sokol at, and it's, yeah, very nice to just sort of change configuration and tweak things. It's got some nice components that you can just basically wire up these inputs directly to your variables. So yeah, so that's kind of it. That's we've yeah, successfully set up Sokol with ImGui. ImGui's very cool library. It's got so many components, lots of cool stuff that you can do with it. But the good thing about this little setup with Sokol is that this is now fully independent little build library we've got here. So there's all the dependencies are within this folder, so we can distribute this very easily. People can just pull it in and just compile it, and it runs. We're not sort of relying on third-party libraries and different version issues, even though we had a version issue before, but that was my bad copy and pasting skills. But yeah, we can just very easily compile that. And when I say there's no dependencies, obviously there always is dependencies, or not always, but like we're still depending on the like core libraries from the operating system. Um, but and the C, the C library and Objective C library, but on most of these standard platforms, they will come pre-installed. So as long as you've got a C compile and a C make, you can just come in here and just, this is a very lightweight little repository with all the dependencies vendored into the repository. So yeah, I think it's pretty nice. So anyway, that's it. Hope you enjoyed that. Hope you learned something, and yeah, let me know if you've got any questions about it and whether you enjoyed it, and give it a like. See you later.